Yeah, hello. Welcome to our discussion panel here about voodoo or science. So what is the way for really good sound? And I have the pleasure to have four guests here that will help me to have an interesting discussion. To the left is Paul Miller. I think everybody must know Paul Miller. So he's president of EISA. He's running Hi-Fi News, the oldest magazine we have on this planet. And I think also Stereophile now, Stereophile. So he probably has measured more equipment, hi-fi equipment, than anybody else on this planet, because he developed his own measurement system that is still one of the advanced one you can buy. So he definitely knows about the scientific part of the market and knows all the products. And I'm pretty sure he can tell us a few nice stories. The next one is Reiner Fink. No, he's not my brother. So he writes, his name is written a little bit different. We know each other since 35 years, almost 40 years. So he's coming from from Philips originally, and he's then started to work for Marantz. If you talk about the devices in the last 5 to 10 years, everything that got awards and God knows what other results, he designed and tuned. So he is a tuning specialist. It's a pleasure for me that he's now working with us. So he's part of our company now. Wolfgang, Wolfgang Beckmann, because sorry, sometimes I'm bad with names. Wolfgang is coming from a completely different position. So he's making tunings and optimizations of equipment, but not with, changing cables or doing other things like we normally do from the technical side. And maybe he can later on explain a little bit what he is doing. He's not only doing hi-fi, so he recently started to also work with musicians. So that means he's working on grand pianos, and what I understood is that the musicians really like the way he treats the piano, but he can do that also for hi-fi. And I must say that I didn't understand everything, but you should be open. So, but he will tell us a little bit. And then we have Thorsten, and I have to look again. Sorry, Thorsten Feuerherdt. Yeah, sorry. Thorsten is designing digital equipment, I would say. So he's really from the measurement and technology area, digital electronic, musical instruments, but not necessarily, the hi-fi guru that sits in the corner and, changes the cable here and there. But he's trying to make, a perfect digital connection between things. So this is the bandwidth that we have here. My name is Karl-Heinz Fink. I'm running an engineering company in Germany. We do loudspeakers and electronics. I also have another brand that is selling loudspeakers, but that's not so important here. So what are we trying to do? We are trying to explore a little bit what is the situation, where is the science nowadays in hi-fi? You all know that there's a lot of discussion going on forums. Some people say, hey, you can't measure it, so it's not there. So it's all imagination and voodoo and whatever. And you have big followers. There's a website really doing nothing else. And you have other people who say, forget about all the measurements. That's not important. It's only what you can hear is important. And nobody cares about measurements. And I would like to start with Paul, because Paul is the one who is doing both sides. So he is measuring a lot, and he's trying, and what I understood is that half of his life he is trying to find the correlation between what he hears and what we can measure, which is really, really important.
Thank you, Karl-Heinz. Can everybody hear me? Yes? Put your hand up if you can't hear me. Okay. I think maybe it's worth going back to, if you like, the beginning of test and measurement. Where did it all start? And where did the idea of correlation even start? If you go back to amplifier designs in the 1950s, we didn't really have test and measurement equipment, which was, had any kind of resolution then. But the early amplifiers had a lot of noise, very limited bandwidth, very high levels of distortion. So those original measurements that we still do now, frequency response, harmonic distortion, noise, if you go back and look at those amplifiers, well, there really is a correlation with sound quality because they were really bad. So if you get the distortion down from a few percent, that's going to be audible. But it's a whole other thing to think, okay, now we're worried about whether it's 0.50 something percent. It's not important. It's not important. So the title here, Voodoo or Science, well, Voodoo is just the science we don't know yet. So you should definitely trust your ears. If you hear something and you hear a difference, you're not wrong. Not wrong at all. There will be a reason why you can hear a difference. Just because we don't know what that reason is doesn't mean it's invalid. So I always think of, test and measurement and the correlation as it's like a jigsaw puzzle. And we've thrown the whole thing up in the air. We don't know how many pieces are missing. So we don't know what we don't know. So, a good example was I developed a jitter analyzer in the 1990s. And that was a way of actually using, someone else's work. But I developed an analyzer that allowed you to understand where the modulation patterns were coming from. And that did open up a window when we were testing. I used to do groups of CD players for Hi-Fi Choice. We might do 25 CD players in a month or something. And you'd have products, CD players, which ostensibly measured pretty much the same, but they would sound quite different. And once we had the jitter analyzer, we could actually see that was one measurement that allowed you to tell the difference between different products. Some of them had high levels of data-induced jitter. Some might have had power supply-related jitter, and that impacted sound in a different way. But that was a piece of the jigsaw puzzle we didn't really knew existed, and we had it, we could put it in the puzzle. So there are a lot of other pieces of the jigsaw puzzle that we don't know about yet. And that's the fun, if you like, of the research, which sadly with my various other day jobs, I have less time to indulge in. But there we are. So, that's, if that kicks it off.
Yeah, sure. Maybe you can say something about it because, you're also very much into digital measurement and digital electronic. The good thing is that he's working on affordable things because that's another aspect. And the positive thing about the science, because you can do some really good devices that measures very well and they are not crazy expensive. So maybe you can explain a little bit of what you are doing there.
Yeah. Hello. In the end, I'm a digital hardware designer. So I'm designing musical instruments. So I know a lot about music production. Of course, I know a lot of musicians. We are working with pro audio stuff, means I knew a lot about the studio production and the recording. And we are working for some companies here designing high-end clock systems. So I know the whole chain of production, recording, and replay in the end. As an engineer, I'm very happy that I don't have to think about if something sounds good or not, because this is done by the customer. Because my work is to transport data from A to B without any accident. So very stable, no loss of data. That's the main point that I can do. And in the end, if something sounds good or not, even yesterday, I took a train from Berlin to Munich with 300 kilometers an hour, and I was not able to hear anything. So it was strange. I was standing in front of some nice nice speakers, and I said, not today. So in the end, my work is to make a cool, reliable design. And of course, we are measuring. Because if we are talking about jitter especially, this is something what you can measure very well. If we are going into a specific range, it starts to be a little bit hard to measure it. Because I just had a reference clock measurement with a very, very high-end measure system from Rohde and Schwarz, and it was not able to measure it because we are always measuring the internal oscillator of the measurement system. So meanwhile, we are in an area where it's more aerospace and aerospace measurements. If this is the really best way, I definitely not know. So maybe we are, meanwhile, in the end, contains jitter, what we can measure, but that jitter has an influence of the sound is completely clear. I think a good clock system is always good for an audio system. But if it sounds good or not, it's up in the end to the customer.
Can I ask a question? I mean, among audiophiles, for example, the power supply that you use to feed these small boxes that you do, there's a discussion, can I use a small thing that I put in the wall socket, a switch mode power supply? Do I use a linear power supply? Some people do a power supply that is 5 times the price and the size of the unit. Are you measuring those things, or are you considering those things?
Of course, we know in electronic design that the power supply is very important. And the stability and the noise of a power supply, even in oscillators, is very important.
Okay.
But it also depends on the target. If I'm building a system used on stage for recording, for replay in a live situation, I cannot bring 10,000 euro power supply to the stage. So, of course, then we are using something different, what is reliable, what is fitting to the application. Yeah. If it's not fitting in a studio situation, of course, you can do something different. But when we are developing, we have a target. The customer came to us and said, I want this price, I want that features. And I'm the one who said, okay, in this barriers, I can develop that with this result.
Okay, I mean it's an opinion. I think So you work on the technical situation, and you don't listen to it and say, this power supply with this transistor and with this capacitor sounds the best.
Of course, we can hear from time to time differences also in the development, and then I try to make it better. But
I needed this to move to Reiner. Because Reiner is, this kind of hybrid guy. So as an engineer, he has this engineering approach, of course, but he's also somebody who knows a lot about the sound quality of components. A typical engineer will now scream and say, a capacitor that has the same ESR and, the same this and that will sound the same. Unfortunately, that's not the case, because when you listen to it, they sound sometimes completely different. And there are even reasons for that. There's microphonic and God knows what else. But Reiner is somebody who is really working on that. And, one of the questions that I want to ask is, are we measuring the right things? Because, the typical thing that we do today is, response curve and distortion and this and this and this. But does this tell us anything about the sound of a unit? Because as you started earlier, we came down from 5% to 0.000 whatever. Does it help if we add another O? I started to mention the website in America that is very much into those measurements, who said, this one has 60 B more He's than on the top of the of the group. So, Reiner, is that different, or do you have a different view? Is that important, or does it say anything about the sound?
So first of all, I would like to not go back to the 50s, but to the mid-80s, the time the CD came up. That was also the time I started to work in a Philips lab. And at that time, the young engineers were put on the new projects because CD and digital audio was just starting. And at that time, we had very little measurement equipment available. Because the CD players, all of a sudden, the DA converters, even the first generation, was better than most of the measurement equipment we had. And measuring, let's say, dynamic range was very difficult because there was just a very limited level we could measure because the noise and the distortion of the equipment was higher. So at the end, audio precision, the launch of audio precision helped a lot, and a lot of new techniques came up. The jitter measurement Paul introduced helped a lot. And I would like to correct Karl-Heinz a little bit. I moved to Marantz, and I was for a long time working with Ken Ishiwata here in Europe. I was involved in a lot of development, but it was by far not only me who tuned the Marantz product. So credit also to all the colleagues at Marantz and especially Ken. All that said, I'm now moving forward and saying, okay, you have the same specification as in your spec sheet, because in a production or development of a new product, you start with a specification. Somebody is saying, I want this power, I want this specification. So it all starts to hit what marketing or whosoever defined what the product should do. And if you hit this, then you can move forward. And I would say that's where the product or the prototype leaves the bench and leaves the measurement equipment, because a good jitter measurement, just to give you one example, a good jitter measurement on the bench does not mean that we don't have jitter while listening to music. And we had a lot of Voodoo complaints in the early 90s, because I'm not saying we were the first who detected that jitter is a problem or an issue in sound quality, but a lot of people made really bad jokes about us, also in the press. They opened the product, and there was this crystal. It was always very clear near the DA converter or wheresoever built up, and Marantz was then putting some rubber rings around these and telling the people it sounds better with this rubber ring. So what happens by listening to music in a room, having the CD player in the room where you have your loudspeakers, there's a lot of feedback happening. A crystal is a mechanical device, and if you start moving it around, then it's changing its frequency, and we have jitter. If it's just standing on a bench, no speakers around, nothing, it measures maybe perfectly. If you listen to music, you have a completely different situation, because there is maybe, it could be also, some people laugh about it, it could be also the furniture, it can be the cabinet, it can be in a CD player. If you not just measure the deck, it could be the mechanism who's causing certain vibrations. So all of this is all of a sudden a difference, talking about a measurement and what you hear. And there can be correlation, there can be no correlation.
So if I can jump in, some of the early CD players, the DACs, you're talking about microphony with a crystal, absolutely.
Yeah.
You squeeze a crystal. I remember some of the early DACs, you didn't need sophisticated measurement equipment. You just hang the output of a CD player into an oscilloscope, get a pencil, and just tap the DAC, and you would get a substantial output on the scope. So that's like valve microphony. Sorry, loads of ideas firing off of my head when I'm listening to my colleagues. Jitter is really only a problem when it's in the analog domain, if that just makes sense. So jitter in the digital domain actually isn't so important. Provided you can have huge amounts of jitter, provided the jitter window does not exceed a consecutive sample period, so you end up basically losing data, it doesn't matter. It's like a computer. As long as all the data's there and it's in the right order, that's all your program runs. What's important is, and you were saying, you have to have the clock as close as you can get to the DAC. It only becomes a problem because we hear in the analog domain, not the digital domain. And the manifestation of jitter is to produce these phase and amplitude modulated sidebands on the analog signal. And that doesn't matter what's come before. It can be full of jitter in the middle of your CD player or DAC or in the system. It's at that point that it matters, and that's the only point that it matters. So that's the distinction. We listen in the analog domain, not the digital domain.
Do you agree with that?
Basically, yes.
But you make clocks.
I make clocks. Yeah, but one other problem is if I'm clocking a digital audio system, I want a single clock, what is reliable and stable for the whole system. So what also can happen if I have in a CD player something what is replaying and I have a digital audio input, or maybe a clock input, or I have a streamer or whatever, I want everything on the same clock domain. And especially while recording, I want a stable clock because I don't want differences in the sample rate. If we are talking about broadcast, maybe it is very important that the clock signal for all instruments, for all parts of the clock system, is stable for a long time due to synchronization in the end. And what definitely can happen is when the clock is not very stable and it's different on different parts in your setup, that you can hear clicks while because you are losing from time to time only one sample, or maybe the sample is not correct. If you're losing a sample, you will hear it clicks. But maybe if the data is not correct, you can hear it also, because maybe you don't have the full range that the signal had. There's a bit missing. Yeah, and in this case, of course, it makes sense to have a cool and stable clock system also in the digital domain.
Yeah, I mean, I'm certainly not advocating sloppiness in the digital domain, so keep it all tight. Because if things get sloppy, then you start introducing a radio frequency, EMI noise on ground planes, and you end up with circulating interference between components, and that's a whole other ballgame. Mm.
So let's for a moment jump away from clocks and go to somebody who is really working with his ears and trying to optimize an equipment and a setup so that people have the best feeling or the best experience when they listen, because by everything that we discuss here is more here. So he's more here. And, when we listen to music, normally that's what's happening. I mean, some people in the audiophile world just listening to difference or like to have something here or there or the width of the image. But most of us who are really into music want to get the emotional part of the music. And he's trying hard, but maybe he should explain what he's doing. It's a fascinating position that might not be for everybody. But maybe you explain that, Wolfgang. You can do that.
I try to explain. It's better to have the experience, for sure. But for me, the most important is what you say, that we have a good feeling with the music, that we are in the music and not so much in the brain. And for me, the normal situation is different because we have really nice equipment. I'm sure you are a really good engineer, same. But my customer have this equipment. I sell it for myself 30 years ago, like HiFi equipment. I try to do my best and have the experience that in the living room of the customers, it's not so good as it could be. And I try to change cables, everything what you want to do, or we change the speakers, or the customer do it for themselves. And it's different, but in many cases, it's not really like better. It's another sound, but not really better. And this situation don't satisfy me and the customers also. So I'm looking for, okay, the system is good quality. They pay a lot of euros or other currency and some really high. And the sound is not like that. And my experience, I try to find out what happens, what is the reason why. And I find out that there are many things they have an influence to the sound. One of the first one is like the electricity. And when I start this with the electricity, there were no many people looks for that. Later we have many men who look for to improve. But I find out that it's not only in the system, it's also electricity around. So maybe other, like the fridge or other things, make also problems with the sound system, and you can hear it. And so this is one of my work, to find out which one is not so as it has to be. And this is one, and the other one is we have many other materials in the room, like flowers or chairs or what else. And when you put it out or in or change the position, you find also it's sound different. So this is my work, to look what happens in the room like an energy field. And I try to make it like a harmonic field. And it's difficult to explain, in special because we have not so much time for really, because it's a lot of things who happens in this area. But I studied the old traditional Chinese medicine. And in this one, you have the 5 elements, and these elements have special position. So it's easy that the water gives the water to the flower, to the wood, so it can groove, and the wood can give the wood to the fire, so the fire can burn, and the fire, it's like when it's finished, gives the earth like a good one for the earth. So this one is the circle, and the position is important to give like a improvement. If you turn around, then it's when you take the earth and the fire is finished, and the fire burns the wood, and the wood takes the water. That's the other way around, and it's like a disturbing circle. So it's a little bit explaining that my work is to find out that we have all these things together in this right circling, kind of like improvement.
Okay, that might sound very unusual or strange to you, but I mean, honestly speaking, we spoke together earlier, and I invited him, I think, if he got the time, to visit me and work with me in my listening room. And I would like to follow some of his rules to see if that is different. I had already some experience with somebody else who started with this kind of treatment. Some of it worked, even the guy was gone. Some of it only worked when he was there. So I think we should be open that there is something beyond what we are measuring today. I mean, most of us, I mean, he's the only not strict engineer, so we are always looking from our engineering view on it. But he looks from a different angle. And I said, we spoke about very early looking into the main system. I mean, everybody is doing that nowadays. You get harmonizers and filters and whatever. Because we realize that the power that we get from the power socket is not the 50 hertz thing that you imagine it should be. It's everything else. So that was something that he discovered very early, long before the whole industry jumped on it. So we should really think about it, try it out, and to see if it can improve.
What are the most 3 important impacts that you found in your experience outside the classical world? Because that would give us an idea, where are you looking into, or what did you find most in the cases you're working with customers? What is that influence which is different from what we expect to be there?
Yeah. Now, one of the most important is in the normal situation, you have many, or not many, but you have some other equipment. Don't use it. And when you put it out of the room, it helps. It's very important that you have not so much equipment who is not in function. So this is one of the most important also in the room. And it's another thing we discuss about it. It's like the electricity. In the electricity, when I start, we look for the face. And everybody say, okay, we look for a white man and took him to next hospital. Now we know it, that you can, it's also a measure to check it, no problem. But I find out that's also like a system from the position of the electricity. So we have this 3-1 in Germany, maybe in other countries it's different, but in Germany we have these 3, like the zero, the earth, and the plus. And these 3 have a special position. And when you only change normally in the HiFi equipment, you change because it's to take the camera, to turn around, and you think it's okay. But my experience is when you turn around, you have like the acoustic. You have in one case a little rich sound. It's rich, and but it's not open. And then you turn around, it's open, but it's not rich. So you have to decide, okay, I like this one or this one. And for me, it's not like this good result. So I find out you have to change you have to change something. It's a little too difficult to explain, but you have to change. And then you have plus, you have both. You have the rich and you have the open. And this is very important because you have many equipment normally, and so they work not really like together, so not harmonic. They work a little bit against, and so you have the problem. And this one you can hear sometimes in the equipment like too hard in the sound, in the other frequency, and in the lower frequency it's like woo. So this one of the main things we have to discuss, because for me is this one not like a voodoo, it's a system. And it's easy to realize, but
It's even science. You can prove it.
yeah.
You can measure that down.
I mean, let's come back to what we're discussing. I think most of us do not the same thing than you do, but at least on a smaller level already. I mean, when we do the setup, and that also happened here when we started here on the show, of course, you try out which is the best position, for your connector. In Germany, we can do that. UK, unfortunately, they have to live with it. You can change the position, and it's in fact that sometimes the image changes quite a bit. And we also work with isolation or decoupling. Decoupling not really, but you have some base plates or whatever, and very often when you do it the right way, I mean the whole thing without touching the volume control sounds louder. And I'm always surprised and sitting in front of it as well. And you can do that. I've done that with some people, and you remove the whole thing, and you can hear that the level is going down. I can see Paul looking skeptical.
No, I'm not being skeptical. I think what we touched on, but we're not actually describing is, if you like, the emotional state of the listener, because we all know that listening to music elicits an emotional response. Okay? We don't have correlation and measurement with that. Okay, we don't actually understand. We know that listening to music or whatever, it has a positive beneficial effect on someone and makes you feel good. And some hi-fi systems are better at realizing that than others, but that's not something that we actually have a handle on. When I'm doing measurements, if you read the magazines, you just see a few things I'm talking about. There may be 100 different measurements on an amplifier, but some of them are more important than others because some effects outweigh other effects depending on what you find. And as you're testing, you kind of find your way. It's not like just doing the same tests and you have a list of numbers. It's like a journey when you're testing it. And as you go along, you're looking at the spectrum analyzer. And this is where it becomes less scientific. It all becomes almost like the arts, doesn't it? If you spend your whole life sadly looking at an FFT, you have an instinct ultimately, and this is very unscientific. You kind of get a sense of what that product is almost going to sound like and how it's going to behave with other products. I almost hate to have to say this because that's not very objective, but that's what happens, isn't it? If you spend your whole life doing this.
Yeah. But Paul, do you have, with all your measurements, do you have in your statistics, and it doesn't matter, amplifier, CD player, whatsoever, do you know if the product was class 1 or class 2? Because this is maybe, for example...
I mean, double insulated
just to explain, there's always this three-pin plug, but in class 2, there's only two pins connected, and the ground is not connected. And the ground is usually what you have as a safety ground on metal chassis to protect that somebody can get a shock if something goes wrong in the product. While there's other safety measures that allow not to connect this ground. And I'm a big advocate to cut the ground, because the ground is connected all through your whole house, and this is very much backing up Wolfgang, and it's also connecting the products, and you can get ground loops, you can get antennas, you can get all kind of things that are measurable, not on the bench again, but can be measured if you go to a real system setup.
Can I walk a little bit away from that and ask something else? We both had an experience half a year ago or whatever, and I'm talking now about measurements and is a device good when it measures well? We had a DA converter that we worked on, or that we had to investigate, and we measured it, and it sounded okay, but it measured really not really good. And I said, let me have a look. I have a topping DA converter in around €80 that I bought for my desk system. And I got that one, and that one had 20 dB less distortion. And then I said, you see these new modern or new brands like Topping, Gastard, Avsolo or Veeam or whatever, are really good on having very well measuring systems, because the Chinese people are clever enough to buy the evaluation board and don't walk away too far from the evaluation board. Because then you at least get what the amplifier or the DA converter manufacturer specified. So I know that some of them, and maybe this is the only really positive thing about this website that is measuring all this kind of stuff, you can see what you can do. My question, and that's maybe to Paul, because he measures so many things and he knows so many. If you look into high-end or in, higher end and audio, do you feel that the scientific level those companies are working nowadays are good enough, or are they just trying to trust that they hear everything and not really could be bothered, for example, to get an evaluation board and tries to match the data at least that the evaluation board is giving you?
Okay, so I'm going to not get myself into trouble here by mentioning any brands.
No names.
No names, no Pactrol. In my experience, there are a few people, a few designers, shall we say, in our industry who have a grasp of circuit layout and design, and they intuitively or otherwise understand the impact on the sound. You get some engineers that are excellent at production engineering, and they will produce a product. I'm going to come back to this phrase, measures well, because I hate this. That measures well, and it's a reliable piece of equipment, but just doesn't sound any good, okay? You've got other designers that produce something that kind of looks quite untidy, but sounds a lot nicer. So I'll come back to this phrase, which you see online and elsewhere, about this phrase that something measures well. I mean, what does that even mean, right? When we're trying to measure something, I mean, the first thing is I suppose, if a manufacturer is quoting a specification, if it's an amplifier, so many watts into 8 ohms, so much distortion at 1 kilohertz, signal to noise, whatever. So that's just the basic due diligence of the magazine. We just check that actually it does what it says on the tin. Does it meet the spec? Does it not meet the spec? That doesn't tell you what it's going to sound like. That's the thing. And earthing, you were coming back to earthing. That's a really tricky thing when you're lab testing. Another thing that's not so well appreciated. In a hi-fi system, most of the time, your amplifiers are driving passive loudspeakers. There's no ground in there. When you're in a lab situation, and this is particularly important since 1990s onwards with these kind of bridged Class D type amplifiers, which are a pig to test, is you can't have an earth in there somewhere. But if you've got a test system, that's not like a loudspeaker. You know, you've got a piece of apparatus generating a signal, which is earthed somewhere. That goes into your amplifier. You have an output from the amplifier that goes into a passive test load, but you're also sampling that output. There's somewhere along the line, there's another earth in there. And that amplifier will sniff that earth out. And that's when things start going unstable at very, very high frequencies. If you don't know what you're doing, that affects what's going on in the audio band. And that's why sometimes you see published measurements where a guy says, this isn't as powerful as they say, there's some problem. Well, it's because you've got an earth problem there in the test setup, you just can't see it. So that's most of my time testing these kind of modern amplifiers is actually setting up the test rig and working out where all the earth should be so that you actually get the amplifier in a happy space and it's going to do what it should do if it was connected to a pair of speakers. But yeah, I really rally against this phrase of measures well, because that's kind of meaningless, really. Define well.
So, okay. What's about you? What do you think? Do we need more science in hi-fi to get better results?
It's strange to say in the end, of course. Yes, maybe. I think in the end we need a base where we can compare things. And I'm getting so often feedback from customers who are also owning an audio precision maybe, and say, I measured this and you announced that. And I said, hey, let me know how you measured it. Yeah. And I think we need a base where we can combine things and compare things. That's, I think, the most important thing. Second thing is, I completely agree with the hearing situation, with the designing and measurement situation, and I think it's not fighting each other. We are doing the best that we can do with our knowledge, designing instruments, hardware, clocks, DA converters, whatever. Yeah, we are fighting from time to time against laws and rules, of course, concerning grounding, metal cases, or about power consumption, standby consumption, whatever. Of course, we are struggling with that. And from time to time, I have the problem that customers want too much functionality in a single unit. And this also causes problem. In the end, the best transmission maybe is a wire. Yeah. And if I'm doing electronic components in the middle, I'm changing something. Yeah, and I'm adding noise, I'm adding filters, I'm adding whatever. And if I'm putting too much in a single unit, I have a microcontroller, I have a TFT display with different clocks, not non-audio clocks. Maybe I have a network interface, again another clock, and then I have the audio clocks. And if somebody thinks that this will always be, and in a small box, yeah. So for me as a hardware designer makes it very strange. Digital input on the left, audio output on the right, headphone on the front, and somewhere is the digital part in the middle. Yeah.
Possibly go wrong.
Yeah. What is wrong? Too much functionality that the customer, my customer who wants me to design it, or the end user wants in a single box. And maybe we should think about that, and then this is science. Less is more from time to time.
You have something to say about, do we need more scientific things?
Yes, I need more science, but more open science, because for me it's like, okay, we have the situation that I hear, or my customers, they hear something, And okay, the measure people say, oh, you cannot measure, so it is not there. So for me, it's better they have an open mind and say, okay, they say this is a problem, and they hear the problem. Okay, we look what happens in this area. So maybe we can find a measure to make it more precisely and more like understanding, you know. So the understanding is important because we have both. We have the heart and we have the main, but they have to be together.
Yeah.
So if you separate, it's always not maybe a fighting like but it's not a good situation. And I think it's like we have a limit. So when I hear something and I can explain to you, okay, I do this one, and it happens this one, I can hear it, and you say, okay, I try to find out what happens in this situation, so we can improve both.
That's true.
Yeah? So,
Of course.
Can I answer my own question? The answer is yes. We definitely need more signs. I mean, I'm the loudspeaker guy, so it's a little bit different from the electronic guys. But very often I see measurements of loudspeakers that are absolutely awful. And, you know, I mean, you see it goes up and down and up and down. This is not hi-fi. So, I mean, you know, every loudspeaker manufacturer should be in the position to create a loudspeaker with an even response curve with something that works together. And I mean, Paul is doing measurements, so in his magazines is one of the very few that is doing it today. And I hope we can get more magazines doing that, because the measurement, a good solid measurement, is the starting point, and then you can start to do the listening and do then the fine-tuning. But if you have something that goes this or does 15% distortion or whatever, this will never be hi-fi. This will be nicely voiced, but this has nothing to do with what we are trying to achieve.
Karl-Heinz, you know, you can have a loudspeaker, let's say, with good on and off axis characteristics and nice even response, but it has a modulating impedance trend, and then you connect it with an amplifier with like a 4 ohm output impedance. And then your flat forward response isn't a flat forward response. It's like that again.
Yeah, I mean, that was just, I know, of course I know. I mean, we all know that it works together. But at least on my loudspeakers, I have a switch so
Yes,
that you
you do.
can change that. No, but I mean, what I want to say, I mean, science and technology is important. There is a lot to do. I mean, many things that we haven't discovered that he was saying, many things that we know about loudspeakers, electronic. I mean, we discussed, you know, how should the distortion be shaped? You know, is it better to have a little bit more distortion K2, K3, and then it goes down, or should it be very low and then you have tenth order or whatever? So there's a lot that has to be done, and we can use scientific approach to do that. But at the end of the day, and then I don't know how much time we have, but you know, at the end of the day, we listen to it, and our heart has to listen to it. So the science will help to get a better feeling, and that's what we all do, hopefully, and what we should do.
But if we understood everything, where's the fun in that?
I don't know if we have time to do some questions. Is that possible? Can we do that?
Yeah.
So who has questions?
Being involved in a lot of measurement. Hi, I'm Doug Schneider from Soundstage. Sorry, I'm getting over a bit of a cold. Being involved in a lot of measurements, and we hear about the listening and not necessarily correlating with what the measurement people say you shouldn't be able to hear. I think one of the things missing, and it goes to science, and I go to Dr. Floyd Toole's research at NRC through the 70s, 80s, 90s, is listening has to be scientific. It's very easy to go down that rabbit hole and say, I heard a difference. And then the engineer says, well, no, it shouldn't show. No, I heard it. And we've done many tests internally where you can trick somebody very easily into thinking they heard a difference. And my thing is, before we decide the engineer should change something, we should say, is there really a difference? Before we go down the rabbit hole. In other words, test the listening It's nice to get a nice feel, but are you hearing what you think you're hearing? And if we decide yes, reliably, we can tell a difference, then we go down the rabbit hole. So it's more not a question, but do you agree with that?
Yeah, I mean, yes and no. I mean, I agree with you. But we have a different situation when you talk to people like we who are working with it every day. I mean, I'm pretty sure, that I can hear if something in my setup changes, the tiny little bit because I know that really from backwards and forwards. You can say maybe it's not relevant because, I mean, not everybody has the same kind of resolution and system. Therefore, it is correct that that this has to be validated, that is, listening is okay. But I'm not a big fan of A/B listening because, I mean, these are too short effects. I had this many, many years ago when we did group delay distortion correction, and I had people sitting there and we invited people and do A/B testing. And the result was nothing because, I mean, nobody could really hear anything. They said, okay, forget about it. It's true that you can't hear group delay, forget about it. And then one guy was sitting there and said, can I listen to the system a little bit? I really like it and I don't have the same system at home. I said, sure. And he was listening and I came back after half an hour and I saw that the correction was switched on. And I switched it off and he immediately noticed that and said, what did you do? I think I switched it off. They said, wow. So that means there are effects where you really need, because especially in the time domain where our brain is really sensitive, you need some time. And so the A/B testing, so they two cables with an equipment thing and with a switch. Now,
It's not necessarily the type of testing. It's simply validating some way that it doesn't have to resort to A/B, it doesn't have to, but validating, are you hearing a difference before the rap? Because you do hear many customers say, oh, I heard this.
Of course. I mean, even I cannot say that every day I'm right. I mean, sometimes I hear something and then I say, no, try it tomorrow. And tomorrow morning it's different. I mean, yeah, it depends on where you are in the system on the level. I mean, some of the systems are really, really optimized to the last bit.
So maybe what I like to add to it is during all the years there were certain formats coming up, and I remember the time DVD-A and SACD came up, where we had all kind of discussions about can we hear the extra resolution, or if we go even back a bit further, the time Minidisc and DCC were launched. And I tell you that in one case it was reduction of resolution, in the other way it was adding resolution. And in both cases it was very easy to prove that there is no difference. Yeah, while it is always a problem to show that there is a difference. And that depends not only about the listening equipment, that from my experience depends a lot on the music you use, and if the listener, the test person, is used to that music. Yeah, so that's a little bit what Karl-Heinz is saying. But I think the problem for us with the science is to prove that, yeah, you are on the right track. Maybe you have measurements to back it up whatsoever, but can you prove by listening? And the music you choose, the person, is it familiar with the setup? There are so many variables that you can steer the result. Yeah, if you want to show there is no difference, easiest of all. Yeah, make a lousy setup, choose the music accordingly, and there will not be a difference, even with the most experienced listeners.
Yeah. Do we have more questions?
So sorry for my English first. You speak about time alignment of the clock in electronic device. It's very interesting. But I have a question about time alignment in speaker design. So what do you combine time alignment and phase alignment? That for me is a question very important.
I don't think that time alignment in loudspeakers and time alignment that we are talking about earlier has anything to do with each other. I mean, the time aligned loudspeaker is a kind of miracle, or I think tale or whatever. because I mean every loudspeaker is a bandpass already, so there's so much going on. To say it's time aligned because you shift, and the last thing you will find the acoustic center of a loudspeaker is at the bloody voice coil. So it's everywhere. I mean, in my opinion, I mean, you have to make sure that in the crossover area you get the right phase behavior. You can do something with a DSP, for example, to correct it. But from experience, doing the group delay distortion correction in the mid to high you can hear it if you choose the right music, but it's more important on the bottom end. It's more difficult on the bottom end.
The question is particularly for the bass part of the spectrum, because typically you have bass reflex or something else different that retard the response, the time response in respect to the middle or the treble. So this doesn't matter for you, or there is something else?
I mean,
Thank you.
Every loudspeaker designer in his life have been testing to make the time alignment perfect loudspeaker. Honestly speaking, I found that getting the crossover slopes, the interaction between the two loudspeakers right, I found more important than having a perfect step impulse. Some people like it, I don't, or I don't need it. But that's one of the things, in hi-fi, there are different ways of reaching Rome, as we say. But people use, I hear so often, first order crossover is the best because of phase. And honestly, I'm tired after so many years to explain them that whatever they say, what you get is the combination of the electrical crossover and the acoustic crossover. And the bloody loudspeaker is a bandpass with second order and depending on how it is on the rear. And whatever you do, I only know one loudspeaker, I think Jim Teal tried that. And that the crossover was as big as a door, as your entrance door, because he tried to really get the slopes right. I mean, and no, it's not my style, but other people might think different.
My professional heckler wants to ask a question.
Yeah, my name is Teppo Hirvikunnas from Finland, AV Plus magazine. And a question about the ABX testing, which is also raised earlier here, that in my experience, it's quite clear that, for example, talking about cables, that we have made a lot of cable testing and using AB and X type of comparison. And almost every case it's impossible to define the differences reliably with these cables. And you said about listening longer time the system. Of course, that the hearing is adapting, even if there are differences in frequency response. For example, the hearing is adapting a little bit, and you are listening actually on your own imagination than the real sound. But the question is that how you explain that these ABX tests almost it's impossible to find these differences in real.
Because I mean, the ABX test is here. What you normally do is here. I'm pretty sure if your system, and we are talking about somebody who knows the system, and will have his music that he knows and he enjoys, will hear a difference even if he, changes it and starts again. Because that's more an emotional process than something that your brain does. I mean, I think I'm not so bad in listening, and I'm not sure that I would hear a difference in ABX test in any cables, because you're so distracted with this testing and with the stress, and you have to see switching or whatever, that it might be that, you don't hear anything because everything is covering the difference, the stress. I mean, I must say, and maybe that is the misunderstanding. Some people think cable is the solution to almost everything. No. The question is, how relevant is it? I mean, would your system be a disaster if you have the wrong interconnect? No. So you can have good systems with two different interconnects, even so they sound different. But for example, people come to me and say, yeah, I need more bottom end, can I change the loudspeaker cable? I said, think about room acoustics, because as long as, moving the loudspeaker 3 centimeter makes more influence than all cables on this planet, then please work on the room acoustics and don't try, to invest a lot of money into cables. So the cable thing is really at the very end, when you really have your system working, and then you can play with it. But unfortunately, I must say that a lot of dealers are trying that and say, I don't talk to him about room acoustics because that needs somebody who knows what it is. You better sell him a nice cable and maybe he's happy. But if somebody else wants to answer that,
is it the same thing we talk about jitter in the early days? I think the difference is the same. The difference is so small, in my opinion, that it's the same thing than the cables. Okay, if you move the loudspeakers 3 centimeters, it has matter, it has meaning. But if you have a CD player or DAC with some difference in jitter, does it matter actually?
I don't know. I can only talk about me, on my experience. Maybe Paul and Reiner have a different opinion over you. I think that our human brain, is very much into timing. It was more important to detect the direction of the lion coming around the corner than identifying what kind of wow he's doing or whatever. So I don't think that is the same. So the jitter thing, I think, is different from what a cable is doing. At least that's my experience.
Well, it is. As I was saying earlier, the jitter thing is manifest as sidebands. So that's an analog distortion. It's phase or amplitude modulated sidebands, depending on where they are. This is the masking effect you were talking about with harmonics. And depending on whether it's related to the music signal or not. Typically, if it's a digital, it's anharmonic, it's not correlated to the audio. That makes it more audible. But I can tell you a lot of stories. I can tell you. So in the early 90s, I did some books on cables. I think we reviewed about 300 cables. And we'd have a group of listeners come in for a week, 2 weeks, and all we would do is sit and listen to cables. It's not something you admit publicly, really. But
Paul, we have to. I got the sign that we have to stop now.
We have to stop.
We did it too long.
My story will remain untold.
But maybe next year we meet in Vienna. So thank you to everybody here. I hope you had a little bit of fun listening to us, and we didn't fight each other, but I tried to show you the bandwidth of what's going on, and I hope you enjoy the high-end show and listen to music, not to the equipment. And thank you very much.